Miss O'Brien here, ready to kick off Unit 5. So in this video, we'll be talking about different segments in a triangle, specifically a median and an angle bisector, altitudes, and perpendicular bisectors. And this is my first time using this program, so we will see how it goes. You should have a notes page to go ahead and take notes along with this. So if I start off with a median in a triangle starts at a vertex and goes to the midpoint of the opposite side. So if in red here, I start at my vertex of A of a triangle and go to the midpoint of the other side. Oops, let's see if I can get a line there. That would be my median. And you guys know midpoints cut the other side perfectly in half. So next time you see the word median, you'll be able to mark this information right in here that these parts are congruent. And now there are a lot of different medians in a triangle. So I could have a median that starts at vertex C and goes to the midpoint of my opposite side there. So I'll try drawing that guy in. So there he is. And so that would cut that into two congruent parts. So a lot of things we can do with medians. This is just building some vocabulary here. Next, I've got an altitude of a triangle, and this should not be new vocabulary to you guys. When you found the area of a triangle in maybe even elementary school or middle school, you had to do area, the base times the height, and you couldn't just take like this length right here as the height and this is the base. You had to find like the true height or the altitude of it. So to find the altitude of a triangle, you're going to start at a vertex and you're going to go down until you meet a right angle to the opposite side. And just like our medians, we also have multiple altitudes. So like if I wanted to start at vertex C here and find the altitude, well, I'm going to kind of extend out this side and then try my best to draw a right angle in here. So there you go. So that's my altitude right there. It's this guy right here would be my altitude if I started at vertex C. And so there's another altitude going from A to probably like right about here, okay? But in your notes you should just have starts at a vertex and meets opposite side perpendicularly. You guys remember that means perpendicular. Not my best notes there, but you can take notes at home as needed. So next we've got an angle bisector. Angle bisectors, super cool in my opinion. So if I have an angle bisector, we've talked about this before, you're going to cut that angle in half. We talked about how a segment bisector makes two congruent segments, and an angle bisector makes two congruent angles. So if I'm going to cut this angle perfectly in half, I'm going to go something like that, so that this guy and this guy is congruent. So these are markings that I should have in my diagram, showing that these angles are congruent. So I'm going to say makes two congruent angles. I think that's all I'm going to say. Makes two congruent angles. Not new vocabulary, but in a triangle maybe it's a little different. We're going to look at some other properties of angle bisectors too a little later. And again, just like everything else, I can have multiple angle bisectors here. So if I'm going to bisect angle B here, I'm going to probably go something like that. That's maybe not perfect. And go back and maybe erase that a little bit. It's not perfectly in half, but you guys kind of get the idea. One thing to note is it's really easy to see over here that this part right here is not the same as this length. So it's not the same thing as a median. It might be, but we don't know that for sure, only in specific types of triangles, and maybe we'll get a chance to prove that later. Next, we're looking at perpendicular bisectors of a triangle. So a perpendicular bisector of a triangle starts at one segment of it, one leg side, and it is going to bisect that side perpendicularly. So bisect means it's going to go straight in the middle, so I'm going to start with my midpoint here. And for it to be perpendicular, it needs to go at a right angle. So I'm going to kind of draw in this guy right here would be my perpendicular bisector. I should show that it's making these two parts congruent. So I'm going to say bisects a side of a triangle perpendicularly. Okay, again, there shouldn't be new vocabulary for you guys, but maybe it's been a while, I guess. So, and again, I can have multiple perpendicular bisectors. That looks like about the midpoint there. So if I draw something that's about perpendicular, there we go, that's about right. And I could do something over here too. Let's see, is that the midpoint maybe? Show that those parts are congruent and do a right angle there. Oh hey, that's kind of weird. Kind of meets at the same point. I wonder if we could prove that. Well, maybe another day. Let's go on to the next. I guess that's all four. So one thing I want to say about angle bisectors is that if I take the distance to my angle bisector, I'm going to have it be congruent. So what that means is if I take one part of my angle bisector, and let's say I start here, and I want to find the closest distance to my angle bisector, that distance is going to be the same as the distance from the other side. So if I take a look at that, that's going to mean that if I go kind of straight up here, have this be a right angle, and then I have another right angle that comes right off here, this distance and this distance are the same. Okay, and that goes with anywhere. If I take a point here, this distance and this distance are the same. Remember, the shortest distance is going to be a perpendicular line there. Okay, so something to remember. I should put 2 marks in here since they're not the same. Alright, now we're going to take a look at some examples here. So, for this, I have some funny notation there. If PF is an angle bisector of angle F, and we're given this information, so this is 2x plus 15, and this guy is, well, we actually don't know that guy. We know this angle right here. It's a good thing I'm labeling my diagram, otherwise I might have labeled it wrong. That guy right there is 8x minus 2, and I want to find x. So now I have to think about this relationship. If I know it's an angle bisector, I should mark these two parts as congruent, right? I know that. And if they're congruent, I know that twice this guy is going to be the same as that guy. So I'm going to write that down. 2 times 2x plus 15 equals 8x minus 2. Okay, so now I can distribute that in. I'm going to have 4x plus 30 equals 8x minus 2. And now I can solve for my value of x. So this is going to be 32 equals 4x. Then you can divide by 4 on both sides. So you're going to get 8. Okay. So that's one example of how you might use this. We're going to look at 2 more here. Alright, here's another example. This time we have a median. So IN is the median. So we have to know what that word means. So if you look back at your notes, it means it goes through the midpoint, starts at an angle. So I know that this is congruent to this. And it says HG, which is this whole thing, is x plus 1. And NG, which is this part, is x minus 5. So once again, it's kind of one of those things that I know that this is also x minus 5 because they're congruent, right? So I can do 2 times x minus 5 equals x plus 1. Now some of you might say, well, can't I just add up these two? It's the same thing, right? If I do x plus 5 plus, oh I'm sorry, that's x minus 5. X minus 5 plus x minus 5 and set that equal to x plus 1. Same thing. You can do that. Either way, I'm going to get 2x minus 10 here equals x plus 1. Same thing I'm going to get here. 2x minus 10 equals x plus 1. So you can see how that's going to work out to be the same. Lost my equal sign there. So now I get plus 10 on both sides. So I get 2x equals x plus 11. Subtract x from both sides. I get x equals 11. Okay. One last example here. And I realize I'm going a little faster, so if you have to slow down and go back to the notes, you definitely can. So now we've got TQ is a median. So again, median, we know that that means this is congruent to this. Goes through the midpoint of triangle TMP. Okay? It wants us to find the perimeter. Okay, I better underline that word or circle it. Find the perimeter of the shape if angle MTP is a right angle. So here's our right angle. Notice how I'm putting this all in my diagram, you guys. I'm not just doing it because you're there, like you're listening. It's what I do when I do math, is I have to mark up my diagrams. So, not exactly sure how to start this problem, but I know that I could find this length, right? Because I know that this part is equal to this part. So now I can put that in. So I'm going to say 3x plus 5 equals negative x plus 15. And now I can solve for x. So I'm going to add x to both sides. I get 4x. Subtract 5 from both sides. I'm going to equals 10. Divide by 4. I'm going to get x equals 2.5. Not the prettiest number, but I can plug that back in. So I'm going to plug it back into, I don't know, this guy, let's say. So when I plug that in, I get negative 2.5 plus 15. And that's going to give me 12.5. So if this part right here is 12.5, I could plug it into this guy, but you guys already know what this is going to be. What's this length going to be? Well, this is 12.5, and it's a median. If this goes to the midpoint, then this better be 12.5. So this is also 12.5, which makes this whole length, what I had going on in blue here, was that going to be 25. Now, I wanted to find the perimeter. So if I redraw out my triangle now, this is what I know. Right angle, 24, 25. Perimeter is distance around, right? So I'm missing one of my distances. I'm missing this guy. I'm going to call him Y. But it's a right triangle. My favorite types of triangles, because we can use our favorite theorem on there, Pythagorean theorem. So now I can say this is my hypotenuse, right? So this has got to be my C. So I'm going to do y squared plus 24 squared equals 25 squared. Subtract 24 from both sides, so I get y squared equals 25 squared minus 24 squared. I'm going to do the math there. I need that squared in there. So if I do 25 squared plus 24 squared or minus 24 squared, putting that in my calculator, I'm getting 49. So I get y squared equals 49. Take the square root from both sides. I get y equals 7. So this guy is 7. So now I can go ahead and find the perimeter. So my perimeter is going to be 24 plus 25 plus 7. So let's see, that's going to be 50 minus 1. It'd be 49. Is that right? Yeah. 49 plus 7. That's kind of weird. And so that's going to give me 56 as my perimeter. Okay? Alright, so that was a little bit of a doozy of a problem, but that's for the most part going to be as complicated as it gets. So I want to make sure you saw a variety of problems. So with that, we will see you tomorrow. Have a good day.